In this skill, we're going to be figuring out the final pH of a mixture when we add a strong acid and a strong base together. In this question, a scientist mixes 1.7 litres of a 0.05 molar nitric acid solution with 0.9 litres of a 0.07 molar strontium hydroxide solution at 25 degrees C. We've been given the molecular equation, which shows the formulas of our reactants and products, and we've been given the net ionic equation, which just shows our participator ions. Now, if we have the right amount of acid and base so that they react completely with each other, then we'll use up all the H plus ions and we'll use up all the OH minus ions, and there won't be any extras left over. So in that case, our solution will be neutral in the end with a pH of 7. However, if we have an excess of our acid, our solution is going to be acidic in the end. If we have an excess of our base, our solution is going to be basic in the end. So firstly, we need to figure out how many moles of each reactant are present so we can figure out which is the excess reactant. To do that, we're going to need to use our molarity equation. Let's head to the reference sheet. This is the solutions page of the reference sheet, and here's our molarity equation. Molarity equals the number of moles divided by the volume of the solution. Molarity equals the number of moles divided by the volume of the solution. So if we want to know the number of moles, let's multiply by V on both sides, so that'll get cancelled out. To find the number of moles, we're going to do molarity times volume. So for HNO3, our molarity was 0.0500 multiplied by our volume, which is 1.70. That gets us a number of moles of 0.0850. For strontium hydroxide, we had a molarity of 0.0700 multiplied by our volume, which was 0.900. That gets us a number of moles of 0.0630. So let's go ahead and fill those in to check we got them right. Our next step is to figure out which is our limiting reactant and which is our excess reactant. Now, if our acid and base are in a 1-to-1 ratio in our equation, then that's really easy. We just look for the bigger number, that's going to be the excess reactant. However, in this equation, we have 2 of HNO3 reacting with 1 of SrOH2. So we have a 2-to-1 ratio. So we're going to have to do a calculation to figure out how many moles of strontium hydroxide would we need to react completely with the HNO3 given. So to do that, we're going to convert the moles of HNO3, which is 0.0850 moles of HNO3. And we want to convert moles of HNO3 into moles of SrOH2. So our conversion factor is going to be given from our equation. It's going to be 2 moles of HNO3 is equal to 1 mole of SrOH2. So we're going to have 2 with the moles of HNO3 and 1 with the moles of strontium hydroxide. So we're going to end up cancelling our moles of HNO3, and then we've got 0.0850 times 1 divided by 2 moles of SrOH2. If we put that into our calculator, we get 0.0425 moles of strontium hydroxide. And that's how much we would need to react completely with 0.085 moles of nitric acid. Now, the amount that we have is 0.063 moles. That's more than the amount that we just calculated we need to react completely with the nitric acid. So that means that our strontium hydroxide must be in excess. So let's fill that in now. Our excess reactant is going to be the strontium hydroxide, and our limiting reactant is going to be the nitric acid. Since we have an excess of our base, we know that our solution is going to be basic in the end. So first we need to figure out how many moles of strontium hydroxide remain at the end. We already calculated that 0.0425 moles of strontium hydroxide are going to get used up. So to figure out how many we're left with, we just need to subtract the amount that we had to start with, which was 0.063 moles. And we need to subtract the number of moles that we know are going to get used up by the nitric acid, which we calculated was 0.0425 moles. If we put that into our calculator, we get 0.0205 moles of strontium hydroxide in excess. So we can fill that in here. We've got 0.0205 moles of strontium hydroxide. So how many moles of excess H plus or OH minus ions remain at the end? Now, strontium hydroxide contains 2 OHs in it. So that means for every 1 mole of strontium hydroxide, we get 2 moles of hydroxide ions produced. So we're going to have to multiply our number of moles of strontium hydroxide by 2. So we're going to do 0.0205 multiplied by 2, which gets us 0.0410 moles of hydroxide ions. Let's go ahead and fill that in here. 0.0410 moles of hydroxide ions. Next, to figure out the total volume of the solution at the end, we had 1.7 litres of nitric acid and 0.9 litres of strontium hydroxide. So we're going to have to add that together. We've got 1.70 plus 0.900. That's going to get us a total volume of 2.60 litres. Let's fill that in here. Okay, great. So we know the moles of hydroxide ions. We know the volume of hydroxide ions. Now we're going to use our molarity equation to figure out our molarity. Remember, molarity is number of moles divided by the volume. Our number of moles is 0.041 moles of hydroxide ions. Our volume is 2.60 litres. So if we put that on our calculator, we get a concentration of 0.0158 molar of hydroxide ions. So let's go ahead and fill that in. 0.0158 molar of hydroxide ions. Awesome. So now we're going to use our equation for pH, or in this case, pOH, to figure out the pOH of our solution. Here's the acids and bases page of our reference sheet, and our pOH equation is here. pOH is negative log the concentration of hydroxide ions. So let's go ahead and calculate that. pOH is negative log the concentration of hydroxide ions. So pOH is negative log, and the concentration of hydroxide ions we just calculated was 0.0158 molar. So if we put that in our calculator, we're going to get a pOH of 1.80. But the question asks for the pH. So let's head back to our reference sheet. Here's our equation that tells us the relationship between pH and pOH at 25 degrees C. And our question tells us at the top that we're at 25 degrees C. So we can use that equation. The equation was pH plus pOH is equal to 14. We want to rearrange this to get pH as the subject. So I'm going to subtract pOH from both sides. The pOHs on the left are going to cancel, leaving me with pH is equal to 14 minus pOH. So that gives me pH is equal to 14 minus pOH, which is 1.8. That gets me a pH of 12.2. So let's go ahead and fill that in now. Awesome. So in this skill, we've got lots of steps in each question. The first step is using our molarity equation to figure out how many moles of each reactant are present. Next, we're going to figure out which is the excess reactant. If it's an acid, the solution is going to be acidic. If it's a base, the solution is going to be basic. And if neither is in excess, if they react perfectly with each other, it's going to be neutral at the end. Then to figure out the pH of the solution, we're going to need to figure out how many moles of the excess reactant do we have at the end, and use that to figure out how many moles of excess H plus or OH minus ions do we have left at the end. You're then going to use the total volume of the solution by adding together the volumes mixed together initially, and you're going to divide the number of moles of H plus or OH minus ions by the volume of the solution to figure out the concentration of H plus or OH minus ions. Finally, you're going to use that in the pH or pOH equation to figure pH or pOH out. If you found the pOH, you're also going to have to use that equation for converting between pH and pOH in order to find our pH in the end.